data ecosystem. And again, as you can see in this slide, the data generation happens at the edge through the various sensors and the edge devices, and you have the backend ecosystem wherein you have all these various functional components that process this high volume data and manage the data, and then apply the data either through analytics and the backend AI models, or through real-time applications for real-time decisioning, from where the users can benefit the outcomes of those decisions that are made, or the analytics that are done, the insights. So that's the landscape, and as I mentioned earlier, the high data volume or the big data nature of it, and how AI would apply very well in this kind of scenarios.
Right. So now, when we talk about the AI, the value of AI is its ability to get insights from the data. AI technologies brings the ability to automatically identify patterns and detect anomalies in the data that the smart sensors and device generates. Information such as like temperature, pressure, humidity, air quality, vibration, sounds. These are the different type of data that these sensors are usually generate. And when we before AI compared to traditional business intelligence tools, which usually monitors for the numeric thresholds to be crossed, machine learning approaches can make operations predictions up to 20 times earlier and with greater accuracy. There are other AI technologies like such as speech recognition and computer visions. They comes into the picture. Like when we talk about computer vision is usually helping in performing quality checks upfront in the manufacturing industry. You can apply the computer vision where they can detect the anomalies very quickly, and give you the quality checks information upfront. On this front, Shri, if you would like to discuss on what factors drive the solution approach, if one has to use the AI ML in IoT landscape, basically.
Yeah. So when it comes to solutioning itself, there are a few factors that drive. Obviously, the business objective and the use case, that's the critical factor, right? As we saw earlier, the application of or usage of IoT, the landscape is pretty wide. So the key thing here is what kind of use cases are we looking at, right? That's the key, and that drives what kind of analytics or what kind of data that is being churned. So you say, for example, we are talking about a security camera kind of use case, or we are talking about a quality assurance monitoring camera kind of use case where a lot of visual data is generated, versus say for example a use case where pure text or data has been time series data is generated. So and that is going to be used for certain prediction from a predictive maintenance or other kind of alerts that we may want to get. So that's the driving factor, and then that drives the characteristics, whether what type of data we are handling. So whether it's text, numeric, time series, media, or what data we are handling, and that also defines how the solution look like, the end solution. And obviously the AI techniques are decided finally by the outcomes that are expected out of handling that, and from the data that we are going to look at based on the use case, right? The techniques can be simplistic machine learning or a deep learning kind of or to a complex deep learning kind of use case from a AI machine learning kind of perspective. So that's how people are approaching this, and from a solution to identify what is the right solution and what is the right approach to apply AI or ML in an IoT landscape, and also where to apply it also comes to picture then.
Yeah. And when we talk about AI and IoT, it's again a new buzzword is about the edge computing. So with edge computing, previously what we were discussing is the data is generated by the sensors, and then there are IoT gateways. They are translating the data and then pushing it to the cloud. where all the computing was happening earlier, all the AI ML models were generated and all the analytics were done. But with edge computing, with edge devices, all the data collection and all the computing happens at the, very close to the device itself, basically. So, if you
Yeah,
may want to talk on the analytics, how it is
yeah,
evolving around the edge.
definitely. Definitely. Few years back, when we talked about performing analytics on IoT or data generated from edge device, it was always the data has to be shipped all the way back to a cloud environment or enterprise, and then we had this big data lake or whatever, and then we then use that data for doing analytics. Which means that a lot of the use cases that we were discussing earlier had a time lag, or which means that the effectiveness of those use cases may not be there because shipping the data, doing the analytics at the back end, and then taking action or providing a feedback to the edge devices or to any users, it took time. Now with in the last 2 years, there's been a lot of advancement in the way both the architecture, people looking at the architecture as well as the edge devices. It's evolved quite fast, and there are a lot of technologies and evolution that has happened at the edge. As I said, architecturally, where we last time it was a simple a thin compute connected with sensors, which just basically captured data, and then it was just a connected device rather than a smart device. Whereas now what we see is at the edge, we not only see a connected device, a smart device, but a hardware accelerated kind of device wherein people are looking at where devices are available where you can even do the analytics at the edge, or running models or running analytical model at the edge. So that's what has happened. What this helps, if you click, if you can click, Jeevan, if you, can you click? Yeah. So what has happened because of this? What's happened is we are able to move some of these critical analytical workload towards the edge rather than performing it at the back end, and then all the complex analytical, including the training and other complex inferences, are done at the back end through the backend platforms or cloud or enterprise servers. As I mentioned earlier, the edge devices, they are now capable of having these hardware accelerators. There are scenarios where people are, or there are solutions where there are ASICs cards, programmable and FPGA cards available, like what we use GPUs in the backend servers to enhance the performance of models. Similar concepts are also available now at the edge devices. So that's helping people to deploy models. Like there are many products out there now. They have these visual detection products wherein the image detection happens at the edge, and only the resultant data is sent to the backend server, which also helps in some of these privacy and other security, data privacy scenarios. So those advancements have helped us to perform two levels of analytics, one at the edge level and other one at the backend data management, data processing layer.
Right. See, so when we talk about this IoT, as per the the experts, the total installed base of IoT connected device worldwide is projected to be, around 31 billion units by 2025, and that is basically a sharp jump from 14 billion units that are expected in 2021. So do you think, like, when these devices are keep increasing, then there is a, and the way edge devices are evolving, do you think why edge
Yeah.
analytics is becoming critical in applications of AI, ML, and IoT together?
Yeah, so there are two parts, I would say two parts to it. One is, the management of those devices, the management of those models, deployment of those models. Yes, that's going to be critical because that is still because we are moving some of these analytics to the edge, and as you rightly said, the computation and the analytics are moving. That's why you need a much more again, that's where the IoT gateways are also evolving now to provide those kind of features, and mechanisms like what we will be talking later about the demo. One of the demos that we're going to see also would showcase that. Now, and then with regards to the use cases also that we would apply, that also would be quite rich there. So these are some examples how when in this architecture and with the intelligent edge, how we can do analytics at various levels in the architecture itself, all the landscape. So at the edge, you can do the anomaly detection or any linear regression kind of models that can be executed with the compute power that may be there, or some non-complex deep learning models through the hardware accelerators can be deployed. And then you have at the IoT gateway level, they may become a bit more intelligent also, where device analytics and other device profiling related models or device performance related models can be deployed. And then you can have all your complex deep learning models done at your backend analytic ecosystem that you may have, which may be either it's a cloud-based like from the big providers, or it can be enterprises' own setup that they may have. And you can also apply in the real-time decision hub, which I call it as decision hub, which is a application on its own, wherein we have the complex event processing and the real-time analytics, real-time profiling can be done. So those are the type of various analytics use cases or analytics that can be applied across this landscape, and help to manage this. And try to operationally, split and manage the complexity when it comes to the edge device and the way we want to do analytics.
Yeah, thank you, Shri. Like when we are talking about AI and IoT together, the more and the core part of it would be the IoT infrastructure that is set up. That is very extremely important for AI-enabled IoT adoptions. So we have with us Mr. Hitendra Uppal to present his views on these sites. Over to you, Mr. Hitendra.
Thank you. Do I have to? All right. So, very informative talk, Shri, and just taking it forward from there. Very briefly, before we come to the subject, tell you something about company. We are a 3-decade old company and working in a very niche area of offering data connectivity solutions. Very broadly, we can move data from, or probably we have experience of moving data from one form, physical form to the other, and from one protocol to the other. Fortunately, our own product developments and skill sets have followed the trajectory of how the hardware has evolved over a period of time. So as the hardware changed, we have been upgrading our products to the latest now, the IoT kind of hardware. So whatever I'm going to talk now probably is going to talk about the market trend as well as where we stand vis-a-vis them. We have strong presence in HVAC, power, petrol, oil and gas, water, where our IoT gateways have been performing very well for it quite a good period of time. Next slide, please. Okay, so what has happened? Earlier, if you see, we had data communication, which was pretty slow, working on, say, serial ports up to, say, 960 Bps or 115 Bps. And then now, as the technology moved, we had USB, we had Ethernet up to 1000 gigabit. We had fiber. So different layers evolved, and we have IoT gateways which support all these physical layers. Similarly, wireless also became a part of the automation and IoT infrastructure. And then earlier from say, conventional Wi-Fi that was being there, different technology evolved: Bluetooth, Zigbee, LoRa, cellular, 2G, 3G, 4G, now 5G, RF, NB-IoT, and all this also got, though they were being independently used as separate technologies for certain specific applications, but they are now all becoming a part of IoT somehow or the other. So all these are also wireless.
Mr.
Similarly,
Uppal, I think your voice is little not clear. Can you please check the audio once?
you would say, should I talk a bit louder?
Yeah, I think yes.
Okay, so I'll try and talk a bit louder. So,
Yeah.
I spoke about how different physical layers and different protocols got into the IoT, depending based on the applications that IoT gateways were being used for. Uh, we're talking about different protocols. So earlier conventional instrumentation or automation was say ASCII or Modbus, and then now different as IoT penetrated into power and other segments, the IoT gateway also started embedding protocols like CB, for DMP for power, or maybe hard for instrumentation, or for that matter, Backyathlon, etc. for BMS. And so similarly, when this data was to be put on the cloud, or there were computing on the cloud required, then the IoT gateways needed HTTP, HTTPS, or MQTT, or these similar protocols which would allow you to put it on the web. So these protocols got into play, and then the IoTs embedded these protocols into them. All our IoT gateways obviously have these protocols support. Next slide, please. We saw that how based on the applications and over a period of time, based on situations and use cases, the physicality of automation products got into the IoT gateways for their interfaces and for their protocols. Similarly, there was a transformation into the IoT hardware also. Earlier, I remember we used to use small microcontrollers and device IoT gateways based very specifically on specific customer requirement that they had. We call it IoT gateways now, but there were simpler automation applications where microcontroller based gateways were involved, and then they were more of a wired application. But now with more and more critical applications moving into IoT section, we have the IoT gateways have also moved from the single port wired gateways to say multiple serial ports, multiple Ethernet ports. A huge bank of digital AIs or digital analog AIs and IOs. Again, depending upon how critical or how large that application is. And we have done applications where there are about 256 AIs work together and then keep posting the data on the web. Similarly, as the inputs increase or type of input increase, the power, as he was also just mentioning, the IoT gateways have to be more powerful. They have to process more memory, more data, so they needed more memory. They need faster processors. Now, fortunately, we are seeing that standard hardware is now evolved, and then we have standard hardware available. For example, Raspberry Orange, Raspberry Pi or Orange or single board computers are now available, based on which you can design your products. Obviously, these are options, but I'm saying higher processing capability applications can also be now embedded into these standard boards. Nevertheless, this option of designing your IoT gateways based on a simple 8-bit or 16-bit microcontroller still exists. I feel even now 50-60% or maybe even more applications are still based on very simple conventional application specific hardware, because that is where you would be able to cut your cost. All the standard boards would definitely come with a price tag. Now, another advantage of the standard boards is that you would have APIs and development tools which are available, or there are users groups which are there, and which there's a lot of sharing of data. So even our IoT gateways are now designed with 8-bit, 16-bit Cortex M4 ARM processors, etc. So depending upon the needs, that is how the boards get designed. Next slide, please. So this whole new application of connecting these devices from field to the enterprise or to the cloud comes with many challenges. People are now very much aware that this data, what is the sanctity of this data, how safe that data is, how much can it be trusted in the hands of somebody who's hosting this data, or some devices which are transporting his data to the cloud. So security and safety became a very important factor, and more so with all the devices that were going to be connected to the internet, so having Ethernet port or having cellular connectivity or having WAN ports in the IoT hardware needed to give this assurance to the end user that the data would be safe in our hands or as they pass through our IoT gateways. So securities like VPN, IPsec, TSL, SSL, IPMAC filtering, or maybe even at the device configuration level, multi-layered passwords or some encryption algorithms as the data moves. So all that got slowly into play, and it moved from the conventional IT devices into these IoT gateways and into the hardware. Needless to say, all our cellular routers or NPM gateways or terminal servers are now secured. As we were talking previously about use cases into various different verticals. One of the very important challenge is how is your gateway acclimatized to the environment. Not all IoT applications are in the control room or in the closed environment, but many of these devices are now moving out on the field. So they see very high temperatures and very harsher operating conditions. So one of the needs for these IoT gateways is as a design perspective is that you design products which can cater to higher operating temperatures, or use the components of your controllers which cater to higher temperatures. We are talking about 60, 70, 75 degrees centigrade. And even as it moves out of the normal control room environment, we are talking about different kinds of ingress protection for against dust and water. So many of these issues are now also coming to the making of the IoT gateways mechanical characteristics. I spoke about our experience in power. So where we have transmission, distribution, and substations, and there we see very high amount of surge, and we see a lot of high electrical conductive noise conductivity in these applications. So these gateways again need a different kind of treatment in terms of allowing higher level of surge and ESD protections. The surge and ESD get defined into by levels. So level 0, level 1 means the normal conventional electronic products, and then it goes up to level 3 and level 4, which is the high level of surge and ESD protections. Next slide, please.
Well,
Yeah.
that's a clear
So,
than before.
yeah. Sorry. Yeah, I didn't realize this was the end of the slide. Okay. So in brief, as things moved, as time passed, as applications grew up, the hardware evolved the way we just now discussed. Thank you very much.
Yeah. Thank you very much, Mr. Upal. Now we'll try to move to the use case demo of AI-driven IoT paradigm shift that we're talking about. So we'll try to present the Ionautical IoT platform. That platform is a comprehensive solution for IoT-based device discovery and its effective management through actionable insights. So it's a no-code, low-code solution which supports out-of-the-box protocols. And on top of that, we have built Rika as use case. Rika offers a powerful and versatile cloud-based platform for EV charging industry. It provides central management system, analytics platform, and user and mobile application. We'll see the demo of both the things as Pradeep will take it from here. Pradeep?
Sure. Thank you, Sarang. Let me quickly share my screen. And please confirm whether I'm clear and sound. Sarang, is I'm audible?
Yes.
Yeah, Pradeep, you're audible.
Okay.
Yes.
Yeah, thank you. Okay, so as we have listened from our experts, so basically industry started generating the revenue out of practicing IoT and AI together. Okay, so whenever various industries started practicing this and getting generated the revenue, the automatic problems are coming up. It's something like first you could think like various industry having various different kind of devices, proximal IP based devices, and these devices does the specific kind of job for that particular industry, and then the a problem starts getting complex where platform provider at least should support those various kind of devices, and that's where the various kind of protocol comes and how to adapt those protocols and provide easy device modeling of those various devices into platform. So this is one of the challenges various different protocols supports. So second problem could be like modeling. When I said devices, one of the devices could be a single parameter could be modeled based on the manufacturer, and some other devices again, if you some other devices, something like more powerful devices, can have various different kind of modeling parameters embedded with it, and that should also platform support easily with very less changes into the source code and all. So this is second kind of problem. And third kind of problem, as mentioned, it's something like when you have devices onboarded and you are able to manage the devices. Now second thing is data, right? So data, when various different kind of use cases are there, which generates various different kind of data, then some kind of unified analytics platform should support an AI model with very less changes can support multiple use cases. So that responsibility should somehow it gets triggered to the platform side itself to give the certain kind of unified APIs, so that with very minimal changes, the existing analytics platform can get utilized with the multiple different use cases. So so Ionotical platform is one of the platform which we have built. Let me just try to I've got login. Okay, so Analytical platform tries to solve these three problems, and instead of demo, I'll try to showcase like the how this got implemented and what are the use case we have built and which is into the production getting used. So first problem is something like various kind of protocols, right? So I'll discuss on to the second step. So first, I'm taking second problem as a first. It's something like modeling the devices. So when manufacturer gives the device specifications, it is kind of technical staff's job to model those devices into the platform so that you will be able to onboard those devices and manage their data, right? So this platform gives a flexibility to model these devices UI with the UI based approach. I mean, non-technical person can start modeling those devices, and it is something like this UI will give you to onboard those complete specification, device specification, whether it has one parameter or multiple parameters. So I'll just showcase one of the parameter. For an example, in industrial IoT, OPC UA protocol is getting used quite heavily. It's kind of device application level could be like this fan speed, pump speed, pressure, temperature, which is got coded into the device firmware like this: fan-speed, pump-speed. So these all, and it is something like numeric values or dynamic values. You can model complete devices through this UI screen. And then comes to the protocols, right? So through this inotical platform, we create the after doing onboarding this devices specification, we create the cartridge. So here in the cartridge creation, cartridge is nothing but the combination of the device which we have device specification and the protocol which uses into that particular use case. So we provide out of the box protocol supports where fog gateway or field gateways can get communicated with the cloud. So it is some of the protocols are out of the box. We support MQTT, OCPP, OPC, UA, HTTPS. So when you combine this device model with the connectivity protocols, then third step is to create the scan so that you can discover those devices from the fog network. So it is we create the scan and we provide the connectivity parameters, their port and other all kind of connectivity parameters which is required for each protocol. And then we used to run the scan and onboard those devices. So this is kind of first time job when devices are set up and got onboarded, and then we do the effective management of those devices. Once you onboard those devices, this platform keeps track of stats of one particular value. When I said one particular value, it's something like it keeps the it just keeps showing the state of the current device state. And when we talk about the data, live data which is getting published, telemetry getting ingested into the platform, for that we provide the API, unified APIs. Through that, analytics platform consumes, where they need not to change their applications level, they can build the model on top of that. One of the use case we have built using this particular platform is electric vehicle charging system for Rika, and that is into the production. And before moving to showing that, this particular platform is built on top of the Azure IoT Hub, and scalability and security is quite aligned with that. So electric vehicle charging system is this is the vendor portal for electric vehicle charging system, where each of the vendor who has let's say some devices, they can which is installed into the various location, they can onboard those devices into the platform, and they can manage those devices. They can see the say the alert and other notification, troubleshoot, and all those kind of stuff they can do. And along with that, we provided the analytics platform so that they can see the stats of the transaction of the devices, like how much power consumptions are happening and other stuff. So this is got built and it is in production on top of inotical platform. Apart from this, when you talk about the electric vehicle charging system, vendor as well as the analytics platform, we do have the user application, because owner of the vehicle, he suppose if I have a vehicle, I want to charge when I travel from one city to other city, then I can, through that mobile application, you can download into the Play Store, which is Rika. You can type and download and play around. It's something like you can locate the which all devices are available into your way from one city to other city, and you can do the prior booking of it, and it gives the complete control of the devices. Because if you talk about the charging plaza, then your petrol bunk, it's the difference is something like petrol bunk, somebody is going to assist you, but in the charging plaza, it's your vehicle may take 2-3 hours to charge, so they cannot afford physical staff to be employed there. So So we have given the control into the mobile itself, where you drive to the exact location and connect your vehicles to the exact device which you have booked. And that and after connecting, you can start the charging from your mobile itself, and then you can track like how much percentage of charging and all is done, and then you can stop the charging and do the payment, wallet transactions, everything, and yeah, and you can happily complete the transaction successfully. So this is about the platform which we have built and try to solve some of the industry's problem. I would be more happy to answer your questions on that. So thank you. Over to you, Sarang.
Yep. Yeah. Okay. Thank you, Pradeep, for that. So thank you very much. So as we have seen that we have underlined the importance of AI-enabled IoT management, and we discussed various facets of it, like its nature, effectiveness through infrastructure, and we also saw the demo of it. So as we now move into the 5G is going to be adopted in not too distant future, one of the famous quote goes by George Allen that the future is now. So we have to be better prepared for that, and the application of AI across IoT will only increase. So we hope that this discussion was helpful for you, and the good discussion would not be fulfilled without good questions. So we hope that any questions or queries or comments that you want to have, we'll be welcoming that here. So anybody has any questions?
Hi, my name is Shailesh. Am I audible?
Just a second. Yes, you're audible.
Hi, my question is, can the IoT gateway directly connect with the aeronautical platform, or does it just connect through the sensors?
So I would like to answer this. So basically, we provide, we support both fog as well as the gateway and the sensors. So your devices directly can connect to the aeronautical platform, and your field gateway also can connect to your aeronautical platform. In that case, I will be giving one SDK to you to install there, so that, or some extra clients we will be giving, so that you will be able to do that. And third is it's a kind of fog network. If the local server is there into the network, where we can pull, and if you're managing the devices there into the local, we can pull those data into the cloud, and we can manage into the cloud. So all three kind of connection we provide.
Okay.
Thanks. That was helpful. Thank you very much.
Yeah. Apart from this,
I have one question.
yeah, please identify yourself.
Yeah, I'm Rakesh Narula.
Okay.
I wanted to know, I work a lot in the typically power T&D industry. So I wanted to know from Mr. Pradeep whether there is a use case you have worked on in the power T&D industry, transmission distribution industry.
So not exactly on that, but I would say in energy sector, definitely I've got couple of use cases to execute. One of them was into the windmill sector, where various kind of parameters get captured through their local server, like wind speed, direction, and temperature sensor, and many other factors, which is very important to predict how much power you are going to generate into the next 7 days, and it is like a very important one. So in that sector I have worked, and one of the energy sector I have worked, where device where there is no central monitoring AC systems. So we were controlling the AC when there are no people available to it. So that use cases was applied into the tier 2 cities bank and the ATMs, where something like those devices doesn't need those much AC to be cold, right? So it is something like if temperature goes beyond 20 degrees Celsius, just switch off the AC for some time, so that you can and the revenue part of, you can think of this something like, if you install those devices are just so cheaper, you can manage them, and you can get the prices cut from the electricity, how much you are paying into the on how much you are saving onto it itself.
Yeah. Okay. Okay. Yeah. That's interesting. Okay. Thank you. Maybe there are some cases I would like to, discuss separately with you.
Sure.
Sure,
Sure.
Rakesh, we can discuss on the use cases. Definitely, there could be, we can identify use cases, and our analytical platform is very generic and can be applied in different industries as well. So definitely, we can discuss with you on that part.
Thank you.
Yeah. Anybody else?
Hi, my name is Sitaraman. I have one questions on the EV charging dashboard. Is it the payment gateways are already integrated in your portal?
Yes. So payment gateway is integrated, and how we do the payments, it's something like we do the wallet charge prior to it.
Okay.
And for an example, you are no, if you want to book some reserve some charging station, then you should have at least 100 rupees inside the wallet, so that you will be able to do the transaction. So based on the research which we have done, and based on the discussion with the vendors, we found out like 100 rupees is more than enough, sufficient to do some certain kind of vehicle full charge. Or if it is a bit more, it's fine, it can go into the negative. And it is something like when you do the next time yeah, you need to recharge again.
Okay, so we need to maintain the 100 rupees in the wallet.
Yes, exactly. So with this, we are solving a lot of complexities because, after charging, you may run away, right?
Yeah, that's correct.
Yeah. So yeah.
Okay, clear. Thank you. And you have any, let's say, any charging station, any brand, let's say, is compatible to your portal?
So it is actually the OCPP protocol is very a popular protocol now, getting hype on this, and our platform is OCPP compliant. So many devices are like proprietary protocol. So we provide like OCPP compliant server. And definitely we currently we have integrated with GBT, which is a kind of a different kind of connectors will be there when it comes to the different vehicles. It is like Tesla having different models, and Tata having different models. So GBT is quite getting used in India at least. So we are using GBT now. Other connectors are something like CCPA, and others are also available, but we have our devices are with the GBT now. But yeah, it is like irrespective of the connector, our server is able to handle all of them with the OCPP protocol.
Great. Thank you.
Thank you, Siddharth. Anyone else? Yeah, I don't see any. You can raise the hands, or you can just put it in the chat box as well. But okay, so you can reach out to us at contact@telulabs.com for any questions for Pradeep or Jeevan or even Mr. Hitendra Uppal. We'll try to get it answered for you. So thank you very much all for sparing your time for today's webinar. Hope it was useful and helpful and both way mutual as well. So any comments or improvements, you can just let us know. Thank you very much. Good day.
Thank you.
Thank you, Saran.
Thank you, Sharan. Thank you, everyone. Yeah.
Thank you, everyone. Thank you, Mr. Uppal. Thank you, Mr. Sri. Thank you, Jeevan. Thank you, Pradeep.
Thank you. Thank you very much.
Thank you.